All right, I'm going to talk about these images that I drew up, and this is just going to be, well, what I'll get to at the end is just going to be very simplistic, but it's just what I recently saw to describe the photoelectric effect, um, and then just talking about how wave particle duality, or at least the center maxima double node in the single impediment or double slit experiment would work for me just because of the uh, frequency. You could say that the measurement or the PDL, the path distance length in the wave um, of the experiment that isn't really relevant to um, well, I would say like a photonic beam of light. Like if it's a beam of light, then the Occam's razor is gonna definitely defer back to just a constructive theory of reality. But if you have an abstract meaning to that, you can say that the frequency converges on energy. It doesn't the frequency, not the photon. So the photon follows suit of the frequency, but the frequency whenever it hits matter or more expensive matter with more atoms, more activity. Because obviously less activity or redshift is defining this whatever antimatter and its kinetic energy because the universe is imploding on itself in terms of it's expanding, but it's also contracting. I mean, I believe in entropy, so I mean, well, to say that there was the Big Bang and then entropy, also just the the sun, how the sun can exist in like basically a vector in symmetry with Earth, and Earth can have its north and south in terms of the galaxy, in terms of the solar system. That north and south, there can be a vector on either side, and that can be the polarity or the transformation of particles into matter, and that vector. There can also be a vector coming from the sun to say that there is a that there is a real dimensional event if you include the quantum mechanical vectors, like the beam of photonic energy or the photoelectric effect would happen and shift from like the sun to the earth in that manner. And this could also, you know, infer different compounds and chemistry with the other planets in the solar system. And then again, the Big Bang can be a wavelength out or a force out, but then the frequency is going to converge or implode in on itself. So it becomes that 0 point vector or that sinkhole or black hole in terms of general relativity to, promote gravity. Because I mean, I really would take many worlds interpretation equation. I mean, just in terms of craving more of a mathematical approach, I mean, an algebra approach. The many worlds interpretation is an algebra equation. It's not a calculus equation. You know, the E equals mc squared. These are all algebra equations. That's because it's just like the inverse square law. But then something that constructive physics or quantum computation, like deducing to the final nucleus in a particular event in space, like, you know, so the universe is only happening because it's time, and the time is registered as it's registered as, you know, like an event happening in the single universe. But then when people get crazy with it, they say, well, there's other universes and all of that stuff. I would say that that's taking something literally, and it's not meant to be taken literally. It's meant to be an abstraction for the universe, and it's not like evolution where we're talking about a worldly event that is almost critical. It's physics, and it's more. I'm not saying it's fun compared to evolution. I'm just saying it's not the same as evolution. Evolution is a real argument against religion. Physics, on the other hand, doesn't have to be like 100% dogmatic Greek ergodic work that happened, you know, because of the sky and the sun and all that stuff. It doesn't. To me, that's not what it is. Like, evolution is an argument against religion. Physics is just a interpretation of reality. It's not an argument against philosophy. I don't know where that would come from, but in terms of Schopenhauer, I mean, was it Schopenhauer or Schrodinger? I don't know. Schrodinger, I mean, there's something happening in the equation that you want, and there's something happening in the equation, the universal equation, the physical universe, that you don't want happening. Not that you don't want happening, but that you don't need happening. It's you don't need the other effect to happen. You don't need the electron to leave the frequency because the photon knocked it out. Like, you don't need that delta. You just it's something that is still, I mean, I just can't really call it anything other than an unknown, a trail. And they always have to split the universe in half. So they just write their equation, and they write their equation, they do it over time or distance. It's always acceleration. It's always about acceleration, because acceleration can happen from the collision, like from the implosion of the wavelength and the vector, which creates the frequency that the photon will travel through, and the photon will create the kinetic compound, you know, work that is actually happening in the universe. Like, and that's how they always, like, mathematicians can create the universe. They split it in half. They make it two-dimensional, so they run their equation over time, and then they just give you an event, and they can add and divide and multiply and do whatever they want, because they use these vectors as their zero. And if they multiply, then they create new dimensions, and that can be other events that are happening in the one universe. And then if they go the vector route, and they go the zero route, and they go the entropy route, they're saying that, yeah, nothing is destroyed. They're saying the universe was just here for a little while. I mean, I don't see anything wrong with that, because obviously, if something can be created, if something can neither be created nor destroyed, then the inversion of that, it can be created and it can be destroyed. So that's what they're doing. They're just inverting that. And then they always use acceleration because of, I'd say, in my opinion, that the wavelength has to immediately clash. The wavelength is the 1 and the vector is the 0. So they can have a -1 and it'd be a negative, or sorry, it'd be like an inverted wavelength. But if the, and then if they use the 1, then it's the wavelength. So -1, negative wavelength. But if they use the 0, then they're using entropy and they're using the vector and they're using the end of the Big Bang. And in my opinion, that's how it's going. And then, yeah, just quantum mechanics. It has quantum mechanics has structured particles, okay, structured atoms, symmetrical, beautiful, and all that. And the particle universe has chaotic. Well, yeah, I'd say the quantum mechanical universe has atoms that are in order, and the particle universe has atoms that are chaotic. And so the particle universe model can use constructor theory, and they can use quantum computation to develop a more internalized theory, like more inverted, more imploding, more universe imploding on itself, because they have the polarity and the polarity and the magnetism, and that's why the gravity effect is a given, because it's the exchange, or it would be not it'd be cause and effect. The gravity equation would be the cause and effect. So in general relativity, when you have like a Schrodinger equation and you have quantum mechanics, then that's when you basically have to label an event that occurred in the universe, or the universe, like the most basic theory of general relativity, which is the only thing that hasn't been proven in quantum mechanics. Special relativity could be, it's going to have something to do with acceleration, of course. But again, special relativity is a small world perception of physics. But again, so that's why it's one of these constant things. But general relativity is including, this bigger picture. Or yeah, you could just look at gravitational lensing and the Eddington stuff like that. So that's going to be, the difference between your special relativity, what you see, and then the general relativity, which is manipulated. But all the matter is, they're real compounds that we know about, but the manipulation happens through the math, of course. So the math involves an abstraction. The math develops an abstraction, like that vector, again, the frequency moving around the sun, bending the light. It is essentially bending, because it's, again, going to be, in my opinion, it has to be a vector. It has to be the frequency has to be moving to a 0, okay, and the photons have to be moving to a 1. So that's why it's like, coding like ones and zeros, because um, because of this. It has to be like a illogical event, not an illogical event, but like it has to be a incomprehensible event. I would say, like, there's no way that artificial intelligence will ever, you know, show us what's good with this. So, yeah, I've been learning a lot ever since I got away from like just freaking out about kinetic energy. Like, yeah, I've gotten a little bit. So, I wanted to get into some other stuff, but I will try to fit that in. So, I'm trying to fit in some woman who was born 3 years after Einstein. She was also a Jew in Germany that moved to America. She died a lot. She died about 20 years earlier. Her father was a mathematician. She's the Einstein quoted her as the best female physicist ever, and her math, her equations, because she was a mathematician. She wasn't. I don't know if she was even considered a physicist, but her math really helped me understand that just the two-dimensional reality, and then how they cause time, or how they label the event that happened in time in the third dimension. And because she just had loads and loads of just simple algebra equations, just to see how it's all, force and all this stuff. But again, another thing I was talking about is just how this quantum mechanics is going to get into. Well, if you consider Maxwell getting into quantum mechanics, consider Maxwell is the beginning of quantum mechanics, and this is when Emmy Note and or no ether and Albert Einstein were grounding, and yeah, so consider that the beginning of quantum mechanics, and then you would have this math. I lost my train of thought, so it's definitely time for me to shut the fuck up. But yeah, it's always about acceleration, and yeah, it's these about equal to equations. So again, just these different things. So yeah, I don't know. It's fun. It's not like um, it's not like carrying a dinosaur bone to a church or something. It's a lot different. So yeah. Well, I don't know what the fuck, but yeah, the fact that they're taking these many world things seriously, and they're not thinking about I don't know, what do they think about? It's like their whole, they are overeducated, I guess. These many world physicists out there. Yeah, I don't know. I think they get it, but what I wanted to say, I think they get it, they understand, but they have to promote their thing. They have to be positive, and they have to get the free space shuttle tickets for the homeless people. Like, their life depends on it, and that's just the sad part. And it's like, yeah, they haven't really contributed. You can't help physics. Physics, that's what I'm saying. It's not evolution versus religion. It's just physics. So that's what I got.